A box contains 5 red balls and 4 white balls. A ball is selected from the box at random. It is replaced and a second ball is selected at random. Find the probability of selecting 2 red balls, 2 white balls, 2 balls of the same color, and 2 balls of different colors. Now let's use R to represent red and what is the other color there? White. Let's use W to represent it. Now the question says a ball is selected at random. The probability that that ball is red will be number of red. How many red do we have? We have 5 red. 5 over the total number of balls in the basket, in the box. How many balls altogether? Total number will be 5 red plus 4 white. So the total is 9. And the probability of picking a ball that happens to be red, therefore, is 5 over 9. After picking that, you replace it. That is for the first draw, you replace it before picking again. So the number of balls still remain constant, and also the number of reds still remain constant. So the point I'm making here is you pick the first ball, which happened to be 5 over 9 because there are 5 red there and a total of 9 balls. After that, you replace it again before picking again because the question says find the probability that the 2 balls are red, 2 red balls. So the probability for the second draw is also 5 over 9. That is the point there. Because you replace the first one with 5 over 9. Therefore, probability that both are red, 2 red, will be 5 over 9 times 5 over 9, which is 25 over 81. Then B says 2 white balls. How many white balls do we have? 4 white balls. So the probability that the first is white is 4 over 9. The probability that the second is also white is also 4 over 9 because we replace it. Had it been it's without replacement, then that would have been 3 over 8. But in this case, we are replacing it. So the probability that both of them are white, that is 2 white, is 4 over 9 times 4 over 9. 4 times 4 is 16. 9 times 9, 81. I don't think anything divides 16 and 81. So we'll leave the answer down. Then question C says 2 balls of the same color. Now that question is quite different from what you have shown already. It could be that the 2 are red, that is 1, both of them are red, or both of them are white. So probability of 2 balls of the same color is equal to probability that both are red or the probability that both are white. Now, we already know the probability that both are red, which is 20. Unfortunately, I cleaned it. What was it? 25 over 81. The probability of 25 of both are red is 25 over 81, or indicates what? Mutually exclusive. So, and mutually exclusive event, we add the probability. So plus the probability that both are white. Probability that both are white is 16 over 81. The denominators are the same, so we can add the numerator. So 25 plus 16 over 81. 25 plus 16, that is 41. So 41 over 81. Then the last one says 2 balls of different colors. 2 balls of different color. It could be that the first ball is white or red. We have red here first. The first ball is red, the second is white, or the first is white, the second is red. So in that case, probability of 2 balls of different colors is equal to probability that the first is red and the second is white, or the probability that the first is white and the second is red. So in that case, the probability that the first is red will be number of red over the total number of balls, which is 5 over 9. And here indicates independent event, so that is multiplication of probability. So the probability that first is red, which is 5 over 9, multiplied by the probability that the second is white, that is 4 over 9. Then or here indicates mutually exclusive event addition of probability. So here, first is white, that is 4 over 9, and the second is red, 5 over 9. So 5 times 4 is 20, and 9 times 9 is 81, plus 4 times 5 again 20, and 81. The denominators are the same, so we can add the numerator. 20 plus 20 is 40, 40 over 81.